Hello again, everyone. Welcome to our discussion of section 1.4, where we will talk about fractional expressions and what we can do to simplify them. We will also talk about domain and rationalizing the denominator of rational expressions. We've talked about rationalizing the denominator in the previous section, but in this case, the denominator will have two terms rather than one term. So we've talked about how to rationalize a denominator that has just one term. Now we will talk about rationalizing the denominator that has two terms. Okay, and in doing that, we will be using the special product formulas that we've talked about in section 1.3. Once again, I want to remind you the proper way of studying math, which is to skim through this section in your textbook before you watch videos or before you attend the lecturing class, then come to class, and then review your lecture notes. And as you do that, do not look at the solutions, but solve the problems without looking at the solutions. Then compare your solution with the solutions in your lecture notes, in the book, and elsewhere. And of course, complete all the homework assignments by the due date, and then review. Okay, so performing the indicator operations for simplifying fractions entails factoring the denominators so that we know what should be our common denominator, right? Unless you factor the denominator, you don't know what could be a common denominator for that. In this case, fortunately, things have been made easy for us, and everything is in factored form already. So we know that the common factor here would be x times x plus 4 squared, right? That x times x plus 4 squared would have a piece in it that would cover all three denominators. Okay, so let's take that as the common denominator, x times x plus 4 squared. Now, each numerator can be multiplied only by what's missing from its denominator when you compare the denominator with the common denominator. So compare this common denominator with that. What is missing from it? X plus 4 squared. So you got to multiply 4 by the missing piece. So multiply 4 by the missing piece, which is x plus 4 squared. Now compare this common denominator with this x plus 4. What is missing from it? Well, what is missing from it is x times x plus 4, because this is x plus 4 squared, right? This is x plus 4 to first power. So one of these is missing from it. So therefore, minus 8, this is minus 8, multiplied by x, which is missing, and also another factor of x plus 4. Because this is x plus 4 to first power, this is x plus 4 to second power. So one power of x plus 4 is missing from this. So there it is. We multiply minus 8 by that, by the missing piece. How about the last term? Compare this denominator with this. What is missing from it? X. So multiply minus x by x. So minus x multiplied by the missing piece, which is x. So now we have to expand the numerator and simplify it. The denominator, leave it as it is. It's in factored form. We do not want to mess with the denominator. But the numerator, we need to simplify it. So let's do that. So first I'm going to expand x plus 4 squared. So 4 times x squared plus 8x plus 16. How did I know? You can either FOIL this, or if you remember the special product formulas, and let me bring back my previous worksheet. If you remember this, x plus y squared expands to that, x squared plus twice the first term times the second term plus the second term squared. If you remember that, which I asked you to remember from the last video, then you'll be able to expand this very quickly. Otherwise, you'll have to FOIL it, which wastes a little bit time, but you can still get this answer. Then minus 8x times x, it would be minus 8x squared, minus 8x times 4 minus 32x, minus x squared, divided by x times x plus 4 squared. Okay, so let's, in the numerator, we're almost there, but I need to distribute this 4 into that. So 4x squared, 4 times 8x is 32x, plus 4 times 16, 64. Right? Now let me write the rest of it. So let's simplify this a little more. 4x squared minus 8x squared is minus 4x squared. Minus another x squared, that's minus 5x squared. Then 32x minus 32x, they add up to 0. So that they cancel out. Plus 64 is the only constant, right? Plus 64 divided by x times x plus 4 squared. Can we factor this anymore? No. So I'm going to box that and leave it like that. The next one. Look at the denominators. This one we need to factor, right? That's x squared minus 7 squared. Minus 49 is minus 7 squared. So we can we should factor the denominator where we can in order to find out what should be the common denominator. So we have by the way, we should also, let's also factor the numerator. So that would be x squared minus 2x minus 63. That would factor out to x minus 9, x plus 7. Right? We discussed factoring last class or last video. Now we can put it to good use. Over x, factor this out. X plus 7 times x minus 7 times, that's times x plus 7 divided by x minus 9. Wow, so this simplifies quite a bit, right? So x plus 7 and x plus 7 cancel out. What do we get? We get, let's multiply across. So x minus 9 times x plus 7 divided by x minus 7 times x minus 9. Is there anything else we can cancel? Absolutely. X minus 9, x minus 9. So we have x plus 7 over x minus 7. So we can stop there. Part C, It's a division problem. Okay, so let's factor what we can. The numerator here is fine. So x plus 9. But the denominator is a perfect square and minus another perfect square, right? 5x squared is 25x squared. So we can factor this out as 5x plus 2 times 5x minus 2. Again, I'm making use of this special product. Perfect square minus perfect square is equal to x plus y times x minus y. I'm making use of that. And here we have this. We have 5x squared minus 2 squared. So that's why you have that. Okay, 5x plus 2 times 5x minus 2. Okay, so then divided by, let's factor the numerator and the denominator of the second fraction. So we'll have, factoring this by trial and error, we have, let's see, so 9, so x plus 1 times x plus 9 divided by, factoring this, we have 5x and x. So we need two numbers that would multiply to negative 12 but add up to positive 28. Okay, so looks like positive 6 and minus 2 should do the trick. So 5x times x, 5x squared. Minus 2 times 6, minus 12. Where are the x terms going to come from to give us 28x? Well, 5x times 6 is 30x, minus 2x is 28x. Okay, so this is the proper factorization. We know what to do with division, right? This is how to handle that. We have x plus, let's write the first fraction down. So x plus 9 divided by 5x plus 2 times 5x minus 2. Change the division to multiplication, then flip the second fraction. So we have 5x minus 2 times x plus 6 divided by x plus 1 times x plus 9. So you could simplify now, but if you prefer, you can multiply these things across and then simplify. Either way is fine, but we can simplify now. So x plus 9 and x plus 9 cancel out. This 5x minus 2 and this 5x minus 2 cancel out. We end up with what's left, which is x plus 6 in the numerator divided by 5x plus 2 times x plus 1. Okay, can we simplify this anymore? No. So there's the final answer for that. This one. So again, I hope you've read the section in the textbook. You've downloaded the blank form of this worksheet on your own, and you've been able to solve all of it. And now you're watching this video with your own solutions in front of you. I hope that's that's how you're watching these video series. So, because that's where you're going to catch all the errors that might be in your solution. So the denominator of 6 is 1, right? So we need to have the common denominator here, which means we should do multiply x plus 10 by the numerator and the denominator. There are different ways of thinking about taking a common denominator. Whichever one works for you, use that one. But the common denominator is x plus 10 So now each numerator must be multiplied by a factor of the common denominator that is missing from its own denominator. So compare this common denominator with 1, which is the denominator of 6. What's missing from it? The whole thing. X plus 10 is missing. So multiply 6 by x plus 10. Then we have plus. Compare this common denominator with this x plus 10. What's missing from it? Nothing. So this x should be multiplied by nothing. X. Okay? So let's distribute the 6 into this and then simplify. We have 6x plus 6t, right? Plus another x divided by x plus 10. So 6x plus x is 7x plus 6t divided by x plus 10. And that's where we stop. Okay? That's the final answer. Okay, so this one. Now this should be very simple for you to do, right? Because the common denominator is simply the product of those two denominators. So x plus 3 times x minus 3. And then each numerator must be multiplied by what's missing from its denominator when you compare it with the common denominator. So this 1, what should we multiply it by? Compare the denominator with the common denominator. X minus 3 is missing, right? So multiply this 1 by x minus 3. Then we have a plus, another 1. What should we multiply by that? Compare this common denominator with that. X plus 3 is missing. So multiply that 1 by x plus 3. Okay, so what do we have? We have x minus 3 plus x plus 3 divided by the factored form. Keep your denominator in factored form. X plus x, 2x. Minus 3 plus 3, 0. So we have 2x over x plus 3 times x minus 3. Okay. I hope this matches what you have in your own solution. Let's see this one. So you have the denominator all powers of x, right? So for the common denominator, you will take the term that has most number of x as part of its factors. So this one has only 1x. This one is x times x, so it has 2x as factors. This one is x cubed, so x times x times x, 3 times. X as a factor of itself 3 times. So you take that denominator that has the factor in the largest number of times as the common denominator. So x cubed will be our common denominator. So compare this with this denominator. What's missing from it? X squared. So multiply the numerator 6 by what's missing from its denominator, which is when you compare it with the common denominator, so x squared. Plus 5. What is missing from this denominator when you compare it with the common denominator? X. So multiply 5 by x. The last one. What is missing from this denominator when you compare it with the common denominator? Nothing. So multiply 3 by nothing. So we're just going to write the 3 down. Okay. So that is equal to, let's distribute and simplify. We have 6x squared plus 5x plus 3 over x cubed. So I'm wondering if we can factor the numerator. Let's see. Definitely not. So we'll leave it as it is. So this is the final answer. Okay, so domain and range are two of the most, I think, looking back at my students' work over the years, for some reason, domain and range tend to give people difficulty. I think it might be because of the way they understand it. It's quite, it would be quite understandable if you connect domain and range with the Cartesian coordinate system. So let me draw that here. So x and y. So domain consists of all acceptable values along the x-axis. So that is the domain. All the acceptable values along the x-axis. Range is all the acceptable values along the y-axis. Range. So when you're talking about the domain of a function, you must force your eyes to look at the behavior of a function or all the acceptable values within a function along the x-axis. So if there are any restrictions along the x, you should take those out. And we will talk about those restrictions. Restrictions could be any number that would make the denominator of a fraction 0. So if you have x minus 2 as the denominator of a fraction, then for sure 2 should be excluded because 2 minus 2 is 0, and we cannot have 0 in the denominator. And that's just one example of a restriction. But domain consists of all acceptable values of the independent variable. Most likely we call the independent variable x, right? But any acceptable values of the independent variable is part of the domain. Anything that is not acceptable is kept out of the domain. For range, all the acceptable values of y, or the dependent variable, is considered range. Anything that is not acceptable is left out. Okay, so that's basically what I've mentioned in these two short sentences. Let's see now in practice how we can find the domain of these functions. In this case, we're asked to find the domain. Okay, so domain of this is a polynomial. 4x squared minus 2x, this is a polynomial. All polynomials have domain that has no restriction. So let me write that down. Polynomial there are no restrictions on the domain of a polynomial. Thus, the domain is always negative infinity to infinity. And that goes for all polynomials. All polynomials, and there are infinitely many of them, have domain negative infinity to infinity. The easiest one to determine. Now this one is not a polynomial. This is a rational expression. Now the restriction on the domain, or x-axis, comes from the fact that we cannot have a 0 in the denominator. So x minus 1 cannot be equal to 0. We know that. It would make the whole function undefined. So x cannot be equal to 1. So the restriction on the domain here is that the only value that is not acceptable is the number 1. Everything else is acceptable for the x value, for the value of the independent variable. So now we need to write that. And by the way, this should say, find the domain of the following functions and write your answer using the interval notation. So everything is acceptable except 1. Why? Because 1 makes the denominator 0. So let's exclude it. So minus infinity to 1, union 1 to infinity. Remember in one of the first sections that we covered, we talked about union and intersection. I believe it was 1.1. Okay? So there's the domain. If you have any questions about what's going on here, let me try to explain it using a graph. So here's the graph that models the x-axis, right? And the x-axis goes from, this x-axis goes from negative infinity to infinity, with the 0 in the middle here. So what we've determined that x in the denominator cannot be 1, right? So if 1 is here, we're going to have a hollow circle there at 1. So domain then is everything except 1. So from here to here, sorry, this should be minus infinity to infinity. This should be minus infinity. So we have from here to 1, and then we have here again to this spot. So domain is negative infinity, comma 1, parentheses. Parenthesis indicates that 1 is not acceptable. Parenthesis means 1 is being excluded from the domain. If it was bracket, then we could include 1. But we do not want to include 1. So there's a parenthesis. And the infinity side always gets the parentheses, regardless. So then union this piece, which is 1, right after 1, comma, infinity. So I hope this little graph helps you see where this domain is taken. So here, once again, we have a rational expression. So we know that 90 plus 18 cannot be equal to 0, right? So 90 plus 18 not equal to 0. That means, because it would make the fraction undefined, right? The whole function undefined, not the whole function. So let's solve for t. So 9t cannot be equal to negative 18. Therefore, t cannot be equal to minus 18 divided by 9 minus 2. So in the domain, everything is included except negative 2. We can draw a little graph here to show what we mean. That's negative 2. Let me show it with a hollow circle. Negative 2. Everything is acceptable except from here, except negative 2. So this is acceptable and that is acceptable. So let's write it out. Domain is equal to negative infinity all the way to negative 2. Close parentheses. Parentheses means that negative 2 is excluded. Union the second piece, which is after negative 2, comma, all the way to positive infinity. Okay, that's the domain for that. The numerator is okay for now. There is no fraction in the numerator. There is no radical expression in the numerator. So the numerator is a polynomial. But the denominator here It's also a polynomial, but because it appears in the denominator, we have to make sure that it's never 0. And that's how we ensure that, by restricting the domain to that region. Okay, a radical expression. A radical expression, well, not only a radical expression, but a square root. A square root, or the even root, cannot have a negative inside. At least if right now we're not considering complex numbers. So this is just real. We're finding the domain within the real numbers. We're not considering complex numbers. Therefore, this square root cannot have something that is negative. So everything underneath this radical should be either 0 or something greater than 0. How can we solve for that? Very easily. We can take the x plus 5 and set it to an inequality to greater than or equal to 0 and solve for this inequality, right? What I just said, that which is x plus 5 can never be negative, it can only be 0 or anything greater than 0, I've now set it up in this inequality. So let's solve this inequality for x. So we're going to have x greater than or equal to negative 5. So this is saying that all values that are equal to negative 5 or greater than negative 5 are acceptable along the x-axis. So let's draw a little graph here just to make things clearer. Negative infinity, plus infinity, 0 in the middle. Let's say negative 5 is somewhere here. 1, 2, 3, 4, negative 5. We don't have to draw the graph. I'm just doing it to make sure that you have a visual reference as to what's happened, what these symbols are talking about. So x can be equal to negative 5. It can, right? So let me put a filled-in circle here. And this is negative 5. And then anything greater than negative 5 is also a part of the solution. So the domain in this case would be not parentheses, but bracket, because bracket means the number that appears next to it is part of the solution, is included. That's what the bracket means. So bracket negative 5, comma, all the way to positive infinity. Okay, so this one, part E is very interesting. And again, I hope you've already solved this on a piece of scratch paper, and you're going through this video with your solutions already there. If not, please pause the video, solve the problem now, then come back to the video. All right, so in this case, because not only we have two things mixed, we have a fraction and then, or a rational expression, but in the denominator, we have a radical expression. So we have two restrictions here intermingling with each other. Okay, so how can we then find the domain? Well, see up here, x plus 5 was not the denominator of any fraction. So it could be 0. Because this square root of x plus 5 is not the denominator of any fraction. It's just the function itself. But here, the square root appears in the denominator of a function. So not only inside cannot be negative, or should always be positive like this situation, but in addition to this condition, here x minus 25 cannot be 0, because if it is, it will make the denominator 0 and the whole function undefined, right? So we have two restrictions mixed together here. So in order to solve for the domain, considering both restrictions, we say x minus 25 must be greater than 0, not equal to 0. So like part D, being equal to 0 here is not an option. Why not? Because it's 0, this piece is the denominator of a fraction. We cannot have it equal to 0. If it wasn't, we could have it 0, but not here. So x minus 25, the denominator inside the radical, must be something positive that is not equal to 0, which is that. So now let's solve this inequality for the value of x. X greater than 25. So if that's the domain, then let's get a graphical feel for it. Let's say 25 is somewhere here, and I'm going to put a hollow circle, 25. Then x values that are after that or larger than that, all the way to positive infinity, are the solution. So let's write that down. Domain is parenthesis 25, comma, infinity parenthesis. So the infinity side always gets the parenthesis because we can never reach that far. 25 gets the parenthesis because it will make the denominator 0. So we put a parenthesis to exclude it from the domain. Okay, so here, that's interesting because we have a polynomial in the numerator and the denominator, and we need to know in the denominator, the numerator is fine. There's no radical expression there. There's no fraction, so there's no restriction coming from the numerator. But the denominator, the fact that this denominator can be 0, we need to find all those x values that would make this equation, this denominator 0, and exclude them. It could be 1 value, it could be 2 value. We need to find what those values are. So to do that, let's factor it. If we can't factor it, we need to use the quadratic formula. So that is equal to x squared plus 5 divided by, that's something easy to factor. So we have minus 5 plus 1. So plus 1 minus 5. And that's the correct factorization of that. Minus 5 times 1, minus 5, x times x is x squared. The x terms come from minus 5x plus x, which add up to minus 4x. So now, it's interesting because now we have two values that could make this denominator 0. X equals minus 1 would make the denominator 0. X equals 5 would also make the denominator 0, and we can't have that. So we should exclude those two numbers. So if x plus 1 is equal to 0, then x would be equal to negative 1. Therefore, exclude negative 1 from domain, because that would make the denominator 0. If x minus 5 equals 0, then x equals 5, then we must exclude 5 from domain. Okay, so now there are two values that we need to exclude. Let's draw a quick graph. Again, the graph is not necessary. I'm drawing it just to make sure that everybody who's watching this is understanding what's happening. Negative 1. So negative 1 should be excluded. I'm going to put a hollow circle there. And also 5. Let's put that, a hollow circle, 5. So those two numbers should be excluded. What can be included as part of domain is this piece, and this piece, right? So let's write it up, because this is just a graph. So we can write this piece as parenthesis negative infinity, comma, negative 1, parenthesis or bracket, You guys sitting at home, what would you use, parenthesis or bracket? You should use parenthesis because -1 is excluded, and parenthesis guarantees that. Then union, which piece? This piece from -1 to 5. Once again, parenthesis -1 comma 5, parenthesis or bracket? Parenthesis, correct. So, because neither -1 nor 5 can be part of the domain because they would make the denominator 0 and the function undefined. So the last piece is union 5, right? Parenthesis 5, because 5 is excluded from the domain, comma all the way to infinity. So there is our domain. It's got 3 pieces that you can see on the graph, which 3 pieces these are. Okay, so here, the domain, this is an interesting problem too, and I hope you've done your work and you're back to the video to compare your solution with mine. This is an interesting one because you have a fraction. In the numerator, you have a radical expression, which in the inside of that cannot be negative. You have a denominator, and that denominator cannot be 0. So you have 2 restrictions involved. So let's make that clear. The 3x cannot be negative. And the x plus 9 cannot be 0. Okay, from this piece, from the inside the radical that cannot be negative, then that means 3x must be greater than or equal to 0. It can be 0 because 0 in the numerator is fine. We cannot have 0 in the denominator. So 3x should be something positive or equal to 0. Okay, and solve this for x. Divide both sides by 3. What do you get? X greater than or equal to 0. From the numerator, that's what we have for x. That's the restriction on x from the numerator. Let's see the restriction on x from the denominator. So from here, x plus 9 cannot be equal to 0. Therefore, x cannot be equal to -9. So you have 2 restrictions. The domain is a restriction, you have 2 restrictions. The domain should be the part of the x-axis that satisfies both restrictions. Okay, so which one? So the domain then is, if I'm the first one, this one, it says everything is acceptable except -9. This one says no, only those values of x are acceptable that are equal to 0 or greater than 0. Which one of these is more restrictive? The domain is the more restrictive one. So this one says everything is acceptable except -9. This one says no, the first half of the real number line is excluded. Right? So this is more restrictive. So the domain must follow the more restrictive restriction. So the domain will be, or is, bracket 0 comma infinity. That one. That one is more restrictive. So we're saying that the negative numbers are not included. Why? Because even though in the denominator it would be okay to have anything but -9, -8 would work in the denominator, -10 would work, -100 would work, right? But in the numerator, it'll cause problems. negative 10, negative 9, negative 9, or negative 10, negative 100 would make the inside negative, and this thing expression would become undefined. Again, because we're not considering complex numbers as part of this domain. Okay. So this one wants us, so we're done with the domain. Here, they want us to simplify the following rational expression. Okay, so all they mean is factor things out and see what you can cancel out and keep what you cannot. Okay, so let's do that. So x minus 4 is fine. The denominator is a perfect square minus another perfect square, right? And you know what we have to do there. There. X squared minus another perfect square. So we have that equation. Whenever you have perfect square minus another perfect square, you can factor x plus y times x minus y. So we have x minus plus 2 times x minus 2. Can we, oh, sorry, let me correct that. I mean x plus 4, because this was minus 16, and x minus 4. Okay, is there anything we can cancel? Absolutely. This one and this one can cancel because everything is being multiplied and divided here. So this whole thing can be canceled with this. So we end up with 1 over x plus 4. Here, let's factor things out. Again, the denominator is a perfect square minus another perfect square, right? Right? Because this is, what is that? That's x squared minus 3 squared. A perfect square minus another perfect square. So that'll be x plus 3 times x minus 3. Okay? The numerator can be factored. That's an easy expression to factor. We can factor it as follows. Like that. So now, can we simplify this? Yes. X plus 3 and x plus 3 cancel out. We end up with x minus 4 divided by x minus 3. Okay, so here we have a compound fractional expression or complex fraction, and we need to simplify it. Well, the first thing I would do is take the common denominator in the numerator of this complex fraction, take the common denominator in the denominator, and then simplify. So let's do that. So I'll just put it here. So the common denominator in the numerator is c minus 1. The common denominator in the denominator, again, is c minus 1. Right? In the numerator, the denominator of 1 is just 1, right? So what's missing from the denominator here when you compare it with the common denominator? The whole thing is missing, c minus 1. So multiply 1 by c minus 1. What do you get? C minus 1. Compare this common denominator with this one, c minus 1. What's missing from it? Nothing. So multiply 8 by nothing, plus 8. Here, c minus 1, compare that with the denominator of 1, which is 1. Everything is missing, right? So c minus 1, multiply that by 1, you get c minus 1. Then, what's missing from this denominator when you compare it with this? Nothing. So multiply negative 8 by nothing. So minus 8. So let's simplify. We get, this is c plus 7, right? This is, when you add negative 1 and 8, you end up with c plus 7, positive 7, divided by c minus 1, divided by c minus 9, divided by c minus 1. So I've already mentioned how it's easiest to simplify a complex fraction, right? Take a look at the terms that are farthest away from each other, multiply them, and put them in the numerator. So c plus 7 times c minus 1 in the numerator. Then take a look at the near terms that are closest to each other. Multiply them and put them in the denominator. So c minus 9 times c minus 1. And we've gotten rid of the complex fraction. So can we simplify anything? Absolutely. The c minus 1's cancel out. We end up with c plus 7 divided by c minus 9. Okay, so let's do this one. Here, once again, let's take the common denominator in the numerator and then take the common denominator there, and then we'll simplify after that. So the common denominator in here is x times y, right? X times y. The common denominator here is 3 times x squared times y squared, right? 3 times x squared times y squared is the common denominator there. So now, in the numerator, compare the common denominator with each of these denominators and multiply the numerator of each with the missing piece. So comparing this with this, what's missing from this denominator? X. So multiply x by x. So x gets multiplied by x. Then we have minus. Compare this common denominator with this denominator, x. What's missing from it? Y. Multiply minus y by y. There. The red indicates the missing pieces from the denominator, which we now multiply the numerator by. So now compare this denominator with the first denominator. What is missing from it? Y squared. So multiply 1 by y squared. So 1 times y squared minus. Compare this with this denominator, 3y squared. What is missing from it? X squared. So multiply negative 1 by x squared. Okay, so let's simplify. So we have x squared minus y squared divided by xy divided by y squared minus x squared divided by 3x squared y squared. Okay, so when we were talking about simplifying complex fractions, I said that take a look at the farthest terms, multiply them, and put them in the numerator. So x squared minus y squared times 3x squared y squared in the numerator. Then take a look at the terms that are closest to each other. Multiply them and put them in the denominator. So y squared minus x squared times xy. Right? So now, is there anything we can cancel? For sure. There's a lot of things we can cancel. But before that, notice that x squared minus y squared has this exactly opposite algebraic sign as this one, y squared minus x squared. Here, x squared has a positive coefficient. Here, it has a negative 1 coefficient. Here, minus 1, y squared has a minus 1 coefficient. This has a positive 1 coefficient. So whenever you have situations like that, always you can factor out negative 1 and make the other one look like this one. So let me factor out negative 1 from the numerator. It makes no difference from which one you factor it. But I'm going to factor from this piece -1. So we have minus y squared minus x squared times 3x squared y squared divided by y squared minus x squared times xy. Okay? So now look at these two. They're identical. So we can cancel that out, but we have a -1 here, right? Also, from compare these two. X and y can come, this can cancel from this. We end up with, what do we end up with? With 3xy. Okay, so let's write this down. The final result is minus 3xy. So compare this expression with that, because that is that, but look how much stuff you have here compared with that. So which one would you, this is why it's so important to be able to simplify expressions in mathematics, because you take away everything that is unnecessary and you keep what is important. Because all these things cancel out to this. So this is the same thing as that. Okay, that's why simplification is such an important topic in freshman mathematics. Okay, so rationalizing the denominator, remember we did this before, right? We did this before, but I believe, I'm not sure, maybe it was in section 1.2. But when we did that, we had a one term in the numerator. In the denominator. In other words, let me use a piece of scratch paper here to just remind you about that. So in the previous section, so previously, we rationalized fractions that had one term. Let's say if we wanted to rationalize 1 over square root of 3, that was the question, one term, right? How did we rationalize this? Do you guys remember? We multiplied this by square root of 3 to get rid of the square root, but we also multiplied the numerator by that because we can't multiply the denominator by one thing and not do the same thing to the numerator. And then we ended up with square root of 3 over 3, right? We did things like that. Or sometimes maybe we had, I think in one of the examples was 1 over a square root of 5x, which is again one term, right? This whole thing is one term. How do we rationalize this? We multiplied this by square root of 5x and also the numerator by square root of 5x. And we ended up with square root of 5x over 5x. So the radical expression was gone from the denominator because we were rationalizing the denominator. Sometimes you're asked to rationalize the numerator, sometimes, but not in vast majority of cases. You will be asked to rationalize the denominator. Okay, so now with this, we don't have one term, we have two terms. Look at that. Two terms, right? So whenever we have two terms, just remember, you got to multiply the denominator by the same terms with the exception that minus should be plus. If you have plus, it should be minus. So in this case, I have minus, so I have to multiply this by 5 plus square root of 24. And of course, we have to do this to the numerator, 5 plus square root of 24. Why are we doing this? Because to get rid of the radical, you must convert this term to a perfect square. Because if you have square root of 24 squared, then you will end up with 24. But you want to do this in a way such that you don't end up with another radical expression. And the best way to guarantee that is to use, again, this one, this identity from section 1.3, this property. Remember that? And on that worksheet, I'm specifically saying that this is used extensively when rationalizing fractions. That one, not these, that one. So doing that, multiplying this by the same two terms, with the exception that the middle's algebraic sign becomes its opposite, guarantees that you will have a perfect square. You will have a perfect square for both terms, and the radical expression cancels out without generating a new radical expression. That's the way to guarantee it. Okay, so now in the numerator we have 5 plus square root of 24 using this identity, that one, right? Well, let me write it so you can see it clearly. Multiplying these two, what do we have? We have 5 plus square root of 24 times 5 minus square root of 24, right? Now compare this with this identity from section 1.3. If you have x plus something times something, that same thing minus that same thing, you can write them as x squared minus y squared. Perfect squares. So let's do that. So that will lead to 5 squared minus square root of 24 squared, right? Which is what we have here. Do you see the connection? This is very important. I hope you're seeing the connection between what we're doing and this identity that we talked about before. I hope you're seeing the connection. So once you have the perfect square, then you can easily simplify the terms. So you have 5 plus square root of 24 divided by 25 minus square root of 24 squared is 24. 24, which is 1, right? So 5 plus square root of 24 over 1, which is equal to 5 plus square root of 24. Okay? Okay, so this one. So if you haven't done this already, please pause the video, answer this question, use this as an example, answer this one, then come back to the video and see my solution. Okay? All right, so I'm assuming you've done that. You're back with your own solution at the ready. Okay, so here we have two terms, so we have to multiply the denominator and numerator by the same two terms, with the exception that change this algebraic sign to its opposite. So 9 plus square root of 7, and do the same thing to the numerator. Multiply the 2 by 9 plus square root of 7. Okay, let's continue. We have 2 times 9 plus square root of 7 in the numerator. In the denominator, we have 9 squared minus square root of 7 squared. Right? Because let me show you this step. So in the numerator, we have 2 times 9 plus square root of 7 divided by, multiply those, 9 plus square root of 7 times 9 minus square root of 7, right? So that allows us to, in our case, this is x, that's y. x plus y times x minus y, right? We're going to make use of this property again. So 9 squared minus square root of 7 squared. Okay, so we have 2 times 9 plus square root of 7 divided by 81 minus square root of 7 squared simply causes the square root of 7 to lose the radical. So we have 7. Okay. Then we have 2 times 9 plus square root of 7 divided by 81 minus that is 74. Positive 74. Is there something we can do to simplify this? Absolutely. 2 is a factor of 74, so we have the 37, right? Yes, 37 here. So we end up with the final answer. So we have 9 plus square root of 7 divided by 37. Like that. I hope this is making sense, and I hope you're seeing the difference between what you do when you rationalize the denominator with one term and when you're rationalizing a denominator with two terms. Okay, in this case, we have same scenario. Please pause the video if you haven't done already and come up with your own solution and then come back to the video. So I'm assuming you've done that and you have your solution ready. So now this is plus. So we're going to multiply this by the same two terms with the sign, algebraic sign opposite to that, like this and that, and we'll have to do this to the numerator as well, like that. So what do we have? We have 5 times square root of 7 minus square root of 3 divided by, what do we have? We have square root of 7 plus square root of 3 times square root of 7 minus square root of 3. We have exactly, so in our case, when you compare this with this, you can see both on the screen, right? Compare this denominator with this formula we have. In our case, x is a square root of 7. Plus, plus, minus, minus. Square root of 3 is our y. Then this is equivalent to the perfect x squared minus y squared, or square root of 7 squared minus square root of 3 squared. Do you see the connection? Very, very important. So let's write that down. We have so let's write it down as perfect square, square root of 7 squared minus square root of 3 squared. What do we get? We get 5 times square root of 7 minus square root of 3 divided by square root of 7 squared is 7 minus square root of 3 squared is 3. So we have 5 times square root of 7 minus square root of 3 divided by 4. So one quick mention, guys, this is not square root of 4, okay? You cannot subtract these two. You cannot say this is square root of 7 minus square root, so that's square root of, no. If you had this, you could subtract. If you had 2 square root of 7 minus square root of 7, yes. This is identical to saying 2x minus x is x. So you say 2 square root of 7 minus square root of 7 is a square root of 7. Or you could say, 5 square root of 3 minus 3 square root of 3 is equal to 5 minus 3, 2 square root of 3. That's acceptable. But you cannot, when the radical expressions are not the same, you cannot subtract their coefficients. Or you cannot subtract the insides or the coefficients. Okay, so we have to keep these separate. Okay, so this one is an interesting one. Once again, we have a minus. And so I'm going to keep everything in factored form because it's easier when we deal with problems like this. So again, I hope you've done this on your scratch paper, and now you're watching the video to find out how your solution compares to mine, which would be great if you're doing that. That would be fantastic. So multiply this by square root of x plus square root of y, right? Both terms the same, except the middle sign should be different. The same thing to the numerator, right? Square root of x plus square root of y. Then let's multiply. So we have 7 times x minus y times square root of x plus square root of y divided by square root of x minus square root of y, in order to be consistent with the formula, square root of x plus square root of y, that one multiplied by this one, square root of x minus square root of y, right? So once again, compare that with this formula. Something plus something times that same something minus that same something is equal to x squared minus y squared. Compare this denominator with this, and watch what happens. Watch what I write. Then square root of x squared minus square root of y squared. Do you see the connection? I hope you do. But that's what is happening. That's why this connection, this whole connection between rationalizing the denominator of a fraction that has two radical expressions and this special product formula is the reason why we're doing this. We're multiplying this by those same two terms with the middle algebraic sign opposite. Okay? So then in the numerator, I'm going to keep things in factored form still. Okay, now let's simplify. We have 7 times x minus y times square root of x plus square root of y divided by square root of x squared is x, square root of y squared is minus y. Can we simplify something here? Take a careful look. Is there anything we can do to simplify? Absolutely. Take a look at the denominator. If you imagine, you don't have to do it, but if you imagine a parenthesis around it, you don't need the parentheses because this fraction line groups x minus y anyway. So you don't need the parentheses. But it's not inaccurate if you put the parentheses around it. Once you do, it gives you a visual sense of what can be canceled. That's why I say put the parentheses, because you don't need it, but it's not inaccurate if you put these parentheses, but visually it immediately tells you, wait a minute, that's the same thing as I have here, and everything is being multiplied, not added or subtracted in between. So you can cancel this and that, and we end up with the final answer, which is 7 times square root of x plus square root of y. Okay, like that. All right, so we get to this last problem, and the last problem wants us to rationalize the numerator as opposed to denominator. Okay, it's just a numerator instead of the denominator, but what we do is no different than what we've been doing. So again, I hope you have done this on your scratch paper. If not, please pause the video, complete the solution, and then come back. Okay, so we multiply the numerator and the denominator by the same two terms, with the exception that the middle sign changes to opposite. Like that, right? All right, so in the numerator, once again, well, let me first write it out. So we have square root of 3 plus, I'm going to multiply, times square root of 3 minus square root of 5 divided by 2 times square root of 3 minus square root of 5. Okay, so let me bring this back so you can see the connection between what we discussed in section 1.3. Like that. Okay, so compare this with what we have in the numerator. Compare the right side with that. X plus y, square root of, let me correct this. So this should be square root of 5. Okay, x plus y, square root of 3 plus square root of 5, times x minus y times x square root of 3 minus square root of 5. So in our case, this is x, this is y, x plus y, x minus y. I hope you see the connection. So now that means we can write the numerator in terms of perfect squares. X squared minus y squared becomes square root of 3 squared minus square root of 5 squared. Okay, let's do that. So this will be 3 minus 5 divided by 2 times square root of 3 minus square root of 5. And that is minus 2, right? So let me so we have minus 2, 3 minus 5 is minus 2, divided by 2 times square root of 3 minus square root of 5. Cancel these, and we end up with minus 1 divided by square root of 3 minus square root of 5. Okay? And then, or you can leave this like this, or you can bring this and multiply it by this and get rid of this dangling negative thing. So this is okay. If you want to leave your answer like that, it's okay. You can also write it like this. That's also acceptable. These are the same answers, but this one doesn't have that negative 1 anymore, negative, because it's been multiplied by the terms in the denominator. So now instead of negative square root of 5, you have square root of 5. And instead of positive square root of 3, negative square root of 3. Both answers are acceptable. Okay, they look different, but they're the same. Okay, so this wraps up section 1.4. And thank you for persisting through this video as well. And for now, have a very nice day, and I'll see you again next time.